What are logarithms? Well, they are the inverses of exponential functions, is the correct answer. But usually that much information is not useful unless we work some examples. So here is what we can consider. Look at this equation. 10 square is 10 times 10 is equal to 100. Now this equation has an exponent of 2 and a base of 10. So this 10 is called the base and this 2 is called the exponent. Now I can rewrite the same equation one other way using logarithms. What I'm going to do is write log, and then every log has a base. The base of the logarithm is the same as the base here, which is 10. And this time I'm going to write 100 by logarithm, and the exponent goes on the right side. So that's how I will be rewriting the same equation. Let's consider one other example. 2 to the 5 is equal to 32. If you multiply 2 5 times, you get 32. Then to write this using logarithms, you would write log, and notice the base is 2, so that's what I'm going to have here. And I'm going to have 32 here, and the exponent would be on the right side. So this is how I want to think. Logarithm to some specific base of a number is that exponent to which the base should be raised to get 32. So it's working in the opposite direction as the exponent. The answer to a logarithm problem is going to be an exponent. Now, let's consider one more example. 3 to the 4 equals 81. You could rewrite this as log base 3 of 81 equals 4. Now let's go in the reverse direction. What would I do if I was given this equation and I want to write in this form? I would be taking this base 3 and I would raise it to this exponent 4, and that would be my answer. So that's how I'm getting 3 to the 4 equals 81. So let's consider log 25 to base 5 equals 2. In that case, you're going to have 5 to the power 2 is equal to 25. Now, if you take log, say, 0.001 to the base 10 is negative 3, then that can be rewritten as 10 to the power negative 3 equal to 0.001. So that's how logarithms work. We can switch between logarithmic equation and exponential equation, and vice versa. Exponential equation to logarithm equations via this process. And in the next couple of videos, we will look at the properties of logarithms, and they all follow from the properties of exponents. We will try to prove as many as we can, but usually the result is going to be so much more important.